After the image has been captured, further processing can be performed to match the settings for the particular body part targeted. X-ray field recognition, grayscale transformation, sharpening, and display enhancement provide you with the optimum image for diagnostic work. When taking X-rays, we use beam limitation to avoid irradiating parts of the body not needed for diagnosis and to minimize the amount of scattered radiation entering the image area. As we see in this figure, the image processing carried out by the CXDI series automatically identifies the collimated region of the image. The green outline is the border of the automatically recognized exposure area. This area can be specified at the operation panel. The image data for the exposure area decided here are ultimately isolated and output onto film, transferred in the form of an image data file, and stored. Grayscale processing is a kind of image processing designed to obtain the same grayscale as film. Grayscale transformation works by referencing lookup tables that are made to match the physical characteristics of film. These lookup tables create an S-shaped curve of the kind shown here. However, referencing a fixed lookup table results in different image densities being produced for different exposure conditions and body parts. Therefore, the S-curve has to be moved to produce images with the proper density. The CXDI system determines how to move the S-curve by measuring features in standard grayscale regions for that particular part of the body. The system adjusts to the different densities that are proper for the chest and the cervical spine, for example, by shifting the lookup tables according to the respective features in those areas. Sharpening is basically a process of unsharp mask filtering, as we see in the picture. Unsharp mask filtering is a process that subtracts the blurred image from the original image in order to generate a high-pass image. This high-pass image is then added back to the original to create a sharpened image. Display enhancement, or DE processing, is used to secure the wide range of contrast existing in image data while capturing it within the limitations of a single sheet of film. The histogram of a chest image, for example, will show a wide distribution from the chest area to the mediasternum. Therefore, when it is placed on the S-curve for grayscale processing, the mediasternum area loses its contrast and the image turns white. In this case, the system compresses the grayscale in the region where the pixels have a lower value than the chest. In terms of the histogram, this is the region to the left of the broken line. This then increases the contrast in the mediasternum area.